Hi. In the previous session, we have discussed about factorial. So what are factorial? Continued product, okay, of n consecutive natural numbers is what? N factorial. Then I've also told you that factorials are not defined for negative reals and fractions. Okay. Then we have seen 0 factorial as 1. Then we have discussed about NPR or P of NR as n factorial divided by n minus r factorial. Okay. Then we have seen NCR or C of n comma r as n factorial, that is the superscript factorial divided by subscript factorial, which is r factorial, into superscript minus subscript factorial. Okay, so all these things are discussed, and we have also seen the relation of NPR and NCR. So what was that? NCR is equal to NPR divided by r factorial, or NPR is NCR into R factorial. So this is what we have discussed, and we have also seen NC0 equal to 1, NP0 equal to 1, NCN equal to 1, and NPN is equal to n factorial. And I told you NC0 and NP0 is same, whereas NCN and NPN are different. NCN is 1 and NPN is n factorial. Then I told you at that time itself, when I was discussing about 0 factorial, take it as 1 by convention, but after knowing one result, I will prove 0 factorial is equal to 1 in the next session, right? So what was that result is basically this: NPN is equal to n factorial. So let me ask you, what is NPN otherwise? What is NPN? So the result is superscript factorial, that is n factorial, divided by superscript minus subscript, right? So n minus n factorial. So n minus n means 0. So here comes 0 factorial. So you will get n factorial divided by 0 factorial. Now we already know NPN is n factorial. So from this you can understand 0 factorial is equal to n factorial divided by n factorial, which is nothing but 1. So I hope this is clear for all of you, how you get a 0 factorial is equal to 1. What is the important result which is required for that? NPN is equal to n factorial, which we have already learned in the previous session, and we have proved it. Now in this session, let's discuss some very interesting and important properties which are required for you in the coming session. Okay, again, which is related to NCR and NPR itself. So let me start off with the first one, that is NCR. You can also write it as NCN minus R. Very interesting. Now let me tell you how you're going to use it and where you're going to use it. See, if I tell you questions like 130 C10 or 130 C2 or 7 C2, etc., you can see R is very small. Okay, so in that situations, you can directly write the formula which we have learned or the shortcuts that we have studied. But there will be certain cases where you get 130 C112 or 130 C122 or 130 C128. Then this is going to be very difficult to calculate, right? Why? Because this is going to be 130 factorial, that is superscript factorial, divided by 128, that is subscript factorial, into 130 minus 128 factorial, which is superscript minus subscript factorial. And doing this is very, very difficult. Okay, so rather you can apply this. When you apply this, what is going to happen? NCR is equal to NCN minus R. So 130 C128 will become 130 C2, and we know 130 C2 is 130 into 128 divided by 1 into 2, which is equal to 65 into 128, and you got the answer faster. I hope this is clear, right? So the point is NCR is equal to NCN minus R, which is useful when R is very, very, very large. So let me explain this concept further. See, here we are actually taking, this is one and this is another. So let me take it as NCX because the superscripts are same. So let me take the same superscript, that is N, but the subscript here is different. So let me take another subscript, but what I am saying is these two are equal. So I am writing NCX and NCY are equal. What is the condition? That is what we need to see. See, the first condition and the only condition which you may think is X is equal to Y. Obviously, if X is equal to Y, then NCX is equal to NCY. For example, see, if N is 7, okay, and x is equal to y, x and y are 5, then you are writing 7c5 is equal to 7c5. No problem in that. Okay, but there will be cases mostly that x and y is not equal. But in that case, how can it be same? Can it be same? In those cases where x and y are not equal, let me take one example. 7c2. Okay, so here n is 7 and x is 2, and if y is 5 here, okay, so if I write 7c5, these two are equal as per this formula. Why? Because here this is r and this is r, so here it is n minus r, so this n minus r is 5. So here also it is equal. Why? Because the subscripts, if you add, that is 2 plus 5, you get the superscript. So whenever you add the subscript, if you get superscript, then these two will be equal. Now clearly I can say 9c4 will be equal to 9c5. The reason is when you add this two, you will get the superscript. Or if it is 11c4 which is equal to 11c7, the reason is when you add the subscript, you will get the superscript. So I hope this is clear for all of you. That is the concept which I have used to find 130C128. I don't want to do this bigger calculation. Rather, what I can do is 130C2. Both will be equal. Why? Because 128 plus 2 will give you 130, which is a superscript. I hope this is clear for all of you. Very, very useful, especially when it comes to your JEE exam, and when you are supposed to deal with this very bigger number where R is big, huge. Okay, so hope it is clear. Let's move on to the next concept, or if you need to go for the deduction, let's go for that. So how will you get this? Let's take the left hand side. So NCR is equal to NCN minus R. This is what we need to prove. So what is the left hand side? NCR. We know that NCR is equal to n factorial divided by R factorial into n minus R factorial. Okay, so let's keep it as 1. Now let's take NCN minus R. So here instead of R it is n minus R. So it will become n factorial divided by, instead of r factorial it become n minus r factorial. Then instead of n minus r it become n minus r. So n minus r factorial. Now this n and n will be cancelled out. This minus and this minus will become plus. So this will become n factorial divided by this will become r factorial and n minus r factorial, which you can mark it as 2. So from 1 and 2 you can clearly see LHS is equal to RHS. Hence it is proved. Okay, so you can straight away use this concept. So what I'm saying is, if the superscripts are same, that let's suppose 9C4, you can get an equivalent of 9C4 just by writing another where the superscript is the same, that is C, and the subscript if you add, you should get the superscript, that is 5. Okay, so to find so let's suppose I am giving you 11C5. What is the equivalent? I need a superscript as the same 11. Then what should be the subscript? 2 subscripts should be giving the superscript. So here superscript is 11, 1 subscript is 5. So other will be 11 minus 5, which is equal to 6. So I need to write C6. These two will be equal. I hope this is clear for all of you. Very important, keep in mind. Now, next important property. See, let's suppose you have n, okay, and you need to find various NCR values. Okay, so let's suppose I am giving you n is equal to 10. Now, what do you mean by all NCR values? It's like NC0, NC1, NC2, etc. All NCR means NCN. Here you can see R varies from 0 to n. Okay, so if n is equal to 10, then it will be 10C1 plus 10C2 plus 10C3, etc. So first will be 0, 1 and 10C10. Now the question is, out of this all values you get in the set, which one will be the highest? Okay, now here there are 2 possibilities. N can be even. Okay, n is even and n is odd. So there will be 2 different maximums in case if n is even and n is odd. So let me discuss the first case where n is even. Okay, so if n is even, then the maximum value out of this will be NCN by 2. Very important. So the maximum value will be NCN by 2. So here you can see n is 10. So the maximum value will be NCN by 2, which is equal to 10C10 by 2, which will be 10C5. Now what is the second possibility where n is odd? So if n is odd, you have maxima, that is NC n minus 1 by 2 and NC n plus 1 by 2. So these are the two maximas if n is odd. So you can clearly see if n is even, you have only one maxima, and if n is odd, you have two maximum values. For example, if your n is 9, what are the maximum values? So what will be the possible NCR values? See, 9C0, 9C1, etc., 9C9. Okay. Now out of this, what are the maximum values? I told you n is odd, so there will be two maximum values. So 9C 9 minus 1 by 2, okay, and 9C 9 plus 1 by 2. So clearly 9C 8 by 2, which is 4, and 9C 10 by 2, which is 5, 9C5. So these two are the maximum values. Now, the maximum values, both are maximum values means both are equal. So the point here is 9C4 equal to 9C5. Now, I hope you can clearly connect this with the previous concept that you have learned. What? See, the superscripts are same, and the subscript, if you add, you get the superscript. So both of them will be equal. Now, the point is crystal clear. What we discussed is, let's suppose, let me give you n is equal to 10, which is even, then it is crystal clear that the maximum value will be 10C2. How you got this? NCn by 2. 10C5, sorry, 10C5, that is NCn by 2. If n is odd, that is, let's suppose 13. Okay, n is odd, then it will be NC n minus 1 by 2 and NC n plus 1 by 2. So you will get 13C6 and 13C7, two maximums. Okay, how? NC n minus 1 by 2 and NC n plus 1 by 2. So this is what you need to keep in mind. So the idea is, if you take NCR values, you may get questions to find maximum. In case odd numbers, there will be two maximums. In case even number, there will be one maximum. And odd number, two maximum will be NC n minus 1 by 2 and NC n plus 1 by 2. Or even maximum, NC n by 2, only one maximum in case of even numbers. Okay, moving on to the next concept. NCR plus NCR minus 1. So here you can see the superscripts are same and the subscripts are differ by 1 and the sum of it. Okay, so NCR and NCR minus 1. I'll give you a simple example. 7C4 plus 7C3. Okay, so you can see the superscripts are same and the subscripts are differ by 1. What is the answer? Answer is n plus 1. That is superscript plus 1. C, the R value, the highest among the subscript. Okay, so you can see here superscript plus 1, that is 7 plus 1. C, highest among this is 4. So 8C4. So if I ask you another question, the very same, 11C3, okay, plus 11C4. Superscript same, this is differ by 1. Addition, you don't want to find what is 11C3 and 11C4 and get the add and get the answer. Otherwise, how will you find 11C3? 11 factorial divided by 3 factorial into 11 minus 3 factorial, right? Then add with 11 factorial divided by 4 factorial into 11 minus 4 factorial. This is not required for us once you know the result. What is the answer? Superscript, which is 11, which is common, plus 1, that is 12. C, highest among this, that is 4. That's your answer. I hope this is clear for all of you. Now, why you are getting this, if you want to know, see, what we have discussed is NCR plus NCR minus 1 is equal to N plus 1 CR. Okay. Now, how you are getting this? If you want to know, let's take the left hand side and right hand side and prove this. Okay. So let's take the left hand side, that is this one, and expand it. So what is NCR? We know n factorial divided by r factorial into n minus r factorial. What is NCR minus 1? So instead of r, it is r minus 1. So how will you write? Plus n factorial divided by r minus 1 factorial into n minus, instead of r, it is r minus 1. r minus 1 factorial. Okay, now here you need to use one result that we have learned earlier. That is n factorial is what? N minus 1 into n minus 1 factorial into n. So you can substitute this r factorial by using this identity. So r factorial will become r minus 1 factorial into r. So this you can write as n factorial divided by r into r minus 1 factorial, then into n minus r factorial. Okay, then write this just like that. That is n factorial divided by r minus 1 factorial into, now again apply the deduction here. Now when you apply the deduction, so what is this factorial? N factorial is n minus 1 factorial into n. So this is your n minus r plus 1. So write this as n minus r plus 1. Why? Because this become minus and this minus minus become plus. And minus of it, that is your factorial. So n minus r factorial. Now you can see here this r minus 1 factorial, r minus 1 factorial, n minus r factorial and n minus r factorial, which is common, you can take out n factorial and n factorial. So n factorial divided by r minus 1 factorial. Okay, again into n minus r factorial you will take out, and what is left out will be 1 divided by r, this r, plus 1 divided by n minus r plus 1. Now what is LCM? LCM is r into n minus r plus 1. So you can apply that, n factorial into r minus 1 factorial into n minus r factorial into, now this will go here when you apply LCM, this will go here. So n minus r plus 1 plus r divided by r into n minus r plus 1. This r and r will get cancelled out. Now what is left out? N factorial divided by r minus 1 factorial into n minus r factorial, okay, into n plus 1. N plus 1 divided by r into n minus r plus 1. Okay. Now what you can see here is this 2. What is that? R into r minus 1 factorial. See here, r into r minus 1 factorial, you wrote for r factorial. So this 2 you can write as r factorial. Okay. Then again you see this 2, n minus r factorial into n minus r plus 1. Where you wrote that? You wrote that here. N minus r factorial and n minus r plus 1, you wrote it for this n minus r plus 1 factorial. Okay. So you can write there as n minus r plus 1 factorial. So what you will get? All these things will be culminating into r factorial into n minus r plus 1 factorial. So eventually you will get n factorial. Now one more thing, this n factorial and n plus 1, what is that? That is n plus 1 factorial, right? So you can finally write n plus 1 factorial divided by r factorial into n minus r plus 1 factorial. So that is what we got here. Okay, mark it as 1. Now let's take your RHS. So what was our RHS? N plus 1 CR. Now how will you go for the deduction? You will write it as n plus 1 factorial superscript factorial divided by r factorial, that is a subscript factorial, into n plus 1, that is superscript minus subscript factorial. So if you rearrange it, you will get it as n plus 1 factorial divided by r factorial into n minus r plus 1 factorial. You can mark it as 2. So that is exactly what you got here. N plus 1 factorial, okay, n plus 1 factorial divided by r factorial into n minus r plus 1 factorial. Here also the same. So you can conclude by writing from 1 and 2, you can finalize that NCR plus NCR minus 1 is equal to n plus 1 CR. Now, moving on to the next concept, fourth one, again very important concept. See, if you have NCR and if you need to take n divided by r out, then what will it become? Okay, see, you can write it as n divided by r. So you have taken one n and one r out. So you can write this as n minus 1 CR minus 1. So NCR you can also write by taking n and r out. So n by r, n minus 1 CR minus 1. So superscript by subscript, superscript minus 1 C subscript minus 1. Very simple. Okay. Now, if you want the proof, so where is it applicable? In some cases, if you get questions like this, 10C4, how will you apply this? So you can first take out 10 and 4. You take 10 and 4, then you can write as 9C3. This further you can continue 10 by 4 into 9 by 3. From 9C3 you can take out 10C3. Now, from 9C3 you can take 9 by 3. Then you write 8C2. Right? Then from 8C2 you can do the same. So 10 by 4 into 9 by 3 into 8 by 2 into 7 by 1 or 7C1. 7C1 is 1. So what you get? You get this cancelled out with 8, 4 and 2. Then this 9 and 3 will get cancelled out. Okay. So you will get 10 into 7, 70 into 24. Now how will you proceed this or what is the proof of it? Let's go for the proof of it. What is given? NCR is equal to n divided by R and n minus 1 CR minus 1. So let's take the LHS. We know NCR is equal to n factorial divided by R factorial into n minus R factorial. Okay, now you apply the concept of deduction, so you can write R factorial as R into R minus 1 factorial. Okay, so let's apply that. It will become n factorial divided by R into R minus 1 factorial into n minus R factorial. Now what we need it in this format, right? N divided by R format. So take one n from here and R from here. So you can take n by R. So n factorial will become n minus 1 factorial. N minus 1 factorial. Now R minus 1 factorial into n minus R factorial. Let's mark it as 1. Now let's take the right hand side. Okay, so what is the right hand side? N by R, n minus 1 CR minus 1. So which is equal to, let's apply this concept NCR here. N by R, n by R into n minus 1 factorial, superscript factorial divided by subscript factorial, that is R minus 1 factorial, into superscript minus subscript, that is n minus 1 minus R minus 1. So it will become minus 1 and plus 1 and minus R. Okay, so it will become n minus R factorial. So you can clearly see that here n by R, n minus 1 factorial, R minus 1 factorial, n minus R factorial. So n by R, n minus 1 factorial, R minus 1 factorial, n minus R factorial. You can mark it as 2. So by 1 and 2, you can conclude by saying that NCR is equal to n divided by R and n minus 1 C R minus 1. So this is the proof.